Okay, in the last video, I mentioned that one of our solutions had was an extraneous solution, meaning that it wasn't actually a solution, and I found that by verifying the answer. So in this video, I'm going to discuss the importance of verifying solutions to equations, and there's really two main reasons that we want to verify a solution. One, we might have made a mistake. That's common. We might have added when we were supposed to subtract, or multiply when we were supposed to divide. The other thing that can happen is the solution method might have given an extraneous solution. This is not our fault. This is something that is inherently wrong about the solution technique. So let's look at the first example, human error. Reason why we want to check our answer. Let's say we have the equation x minus 3 equals 5. We all know that we're supposed to add 3 to both sides and find that the answer is 8. But it could be that we, for whatever reason, we just forget or we make a tiny error and we accidentally subtract 3 from both sides. This happens a lot. Students find that the solution is x equals 2. If you just left it at that, you would get the wrong answer and lose points on the quiz, test, or whatever. The quick way to check to see if you made a mistake or not is to plug this back in. So I'll plug in and I go, oh, well, 2 minus 3 is obviously not equal to 5. 2 minus 3 is negative 1, so my answer is wrong. So was the mistake because of the solution technique I used, or was it because I made a mistake? And clearly you can see that I made a mistake. I subtracted 3 when I was supposed to add 3. So the correct technique here is obviously to add 3 to both sides and have that x equals 8. And then when I plug that back in, 8 minus 3 does equal 5. So this is the solution. Now the other thing that can happen is the solution that we get could be a mistake of the solution technique. So an extraneous solution, it's a value obtained from correctly applying a valid solution technique to an equation, and yet the value still does not satisfy the original equation. So I have an example for that, and it's absolute value x equals x minus 1. Okay, so we know the solution technique that I've shown in the videos. We set up two equations, x equals x minus 1. And then the other equation is x equals negative x plus 1. Okay, on this equation over here, we quickly find that there's no solution to this equation. You subtract x from both sides, and you have 0 equals negative 1. That's never true for all value. There's not a value of x I can plug in that'll make 0 equal to negative 1. So there's no solution here. Solution. On this one, this equation to the right, I add x to both sides. I have 2x equals 1. Divide both sides by 2, and I find, hey, x equals 1/2. Looking through this branch, I correctly split up the equation to x equals negative x plus 1, like the solution method tells me to. I just multiplied this side by a negative. I correctly added x to both sides to get the x's on one side, and I correctly divided by 2. So I have done all the steps the solution technique has told me to do. Now let's go back and see if this is the right answer to this original equation. So I plug in 1/2. The absolute value of 1/2 equals question mark 1/2 minus 1. Well, I know the absolute value of 1/2 is simply 1/2. And I also know that 1/2 minus 1 is simply negative 1/2. So it's clear that this value of x equals 1/2 does not solve our original equation. It doesn't satisfy the original equation. So this is an extraneous solution. And the difference, the main distinction between a human error and an extraneous solution is, in this one I could go back and see something that I did incorrectly according to the procedure. I was supposed to add 3, I really subtracted 3. Here I followed the procedure to a T. The answer I came up with did not satisfy my original equation. So extraneous solutions are dependent on your solution technique. In a later video, I'm going to introduce another way of solving absolute value equations. And the method I'm going to give you will not arrive at an extraneous solution for this equation. It's much less susceptible to extraneous solutions than the technique I'm giving you right now. But we're just not ready for that technique yet. That'll have to be for another video.